So now we are on the session 10. So under unit 2, so that is artificial droughts again. So now we will see induced mechanical drought. So in the previous session, so we had seen the forced mechanical drought, but now we'll go through the induced mechanical drought. So in the figure here, I'm shown in the I think if you remember the previous figure in the forced mechanical drought, so this blower is placed before the furnace here. It was placed here, but in this induced mechanical drought, so it is placed between the before the chimney, right? So that is the difference in the forced mechanical drought and induced mechanical drought, right? So here what happens, so in the boiler naturally the burning process of the fuel, and again there is a conversion of water to steam. It is takes place as it is, like the normal boiler. So we are not forcing the air from the boiler. We are not sending the air with a high pressure at the bottom of the grate or the furnace here. So it is takes place naturally. The atmospheric air enters into the furnace here. The burning of the fuel takes place. The fuel gases converts water into steam. Again the flue gases enters the economizer, enters the air free heater. So when it is coming out of the air free heater, so at there we are placed the blower. So whenever the blower starts here, then it creates a partial vacuum in the furnace. It creates the partial vacuum in the furnace, then and the flue passage, right? So since there is a vacuum is created here, then what happens here, the air and the flue gases are drawn through the boiler due to comparatively the high pressure of outside air. Since the boiler is placed before the chimney, then there is a partial vacuum is created in the furnace and the flue passage. So there what happens, then the pressure is more here when compared to the atmospheric air. So then the pressure difference is created because of this boiler. Then definitely the flue gases are coming out of the chimney to the atmosphere. Then it is convenient to produce induced drought, and like in forced drought, any type of fan or blower may be used. Here you can use any type of a blower or fan here to create artificially. So it means that you are inducing the pressure difference mechanically. So because of that, it is called as induced mechanical drought here, right? The next one, we'll see the comparison or differences between forced and induced drought. What is the difference between forced and induced drought? So you have seen already in the case of forced drought, the boiler is placed before the furnace, right? And in the case of induced drought, the boiler is placed before the chimney. So after the air free heater. So then what is the difference between these two now? Forced drought and induced drought, what is the difference? So we'll see. So in the forced drought, in this case, fan is placed before the fire grate. As I told, the fan or the blower is placed before the fire grate. In an induced drought, in this case, fan is placed after the fire grate. The fan is placed after the fire grate. After the fire grate means it is before the chimney only. This is the first difference. Second one is pressure inside the furnace is above the atmospheric pressure. Pressure inside the furnace is above the atmospheric pressure. Pressure inside the furnace is below the atmospheric pressure here, right? Pressure inside the furnace is above the atmospheric pressure. Why? Because the blower is placed before the furnace, right? The air itself is uh, pressurized with high pressure air only you are supplying to the furnace, so that the pressure inside the furnace is above the atmospheric pressure automatically. The pressure inside the furnace is below atmospheric pressure because so the naturally the burning of the fuel takes place once it reaches the chimney. At that point you were placed the blower. So from that place onwards the pressure is above the atmospheric pressure, right? So that is the one more difference between the forced drought and the induced drought. So it requires less power as the fan has to handle cold air. So it requires less power as the fan has to handle the cold air, right? So it requires less power because at the entrance we were not placed the blower here. So the power required is less here. It requires high power as the fan has to handle hot air in the flue gases. The more power is required because you are placing the blower, or you had placed the boiler before the chimney, means it has to handle the hot air. So for that you need the high power. Next, it forces fresh air through the grate into the combustion chamber. Right? It forces fresh air through the grate into the combustion chamber. It sucks the hot gases from the combustion chamber and forces them into the chimney. So this is the difference, right? Forces fresh air. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಫ್ರೆಶ್ ಏರ್ ಅನ್ನ ಫೋರ್ಸ್ಫುಲಿ it sends to the combustion chamber through the grate. With high pressure air, grate ಮುಖಾಂತರ combustion chamber ಗೆ ಹೋಗುತ್ತೆ. ಎಲ್ಲಿ? The forced drought ಅಲ್ಲಿ. Induced drought ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, ಇಟ್ ಸಕ್ಸ್ ದ ಹಾಟ್ ಗ್ಯಾಸಸ್ ಫ್ರಮ್ ದ ಕಂಬಷನ್ ಚೇಂಬರ್ ಆದ್ಮೇಲೆ ನೀವು ಬ್ಲೋವರ್ ಕೂಡಿಸಿರೋದ್ರಿಂದ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ನಾವು, ಇಟ್ ಸಕ್ಸ್ ದಿ ಹಾಟ್ ಗ್ಯಾಸಸ್, ವಿಚ್ ಸಕ್ಸ್ ದ blower sucks the hot gases from the combustion chamber and forces them into the chimney. ಅದು ಸಕ್ ಮಾಡಿ ಚಿಮ್ನಿ ಕಳಿಸುತ್ತೆ. This is the difference. The fan handles the less volume of air. The fan handles less volume of air. The fan handles the more volume of air and gases in this case. Uniform flow of air through the grate and furnace. There is a uniform flow of air exists here, but less uniform flow of air through the grate and furnace in this case. As the leakages are outward, therefore there is a danger of blowout when the fire door is open and fan is working. Right? The leakage ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಫೋರ್ಸ್ಡ್ ಅಲ್ಲಿ, ಸೊ ಫರ್ನೆಸ್ ಮುಂಚೆ ನೀವು ಬ್ಲೋವರ್ ಕೂಡಿಸಿರೋದ್ರಿಂದ ಲೀಕೇಜ್ ಇತ್ತಂದ್ರೆ ವಿತ್ ಹೈ ಪ್ರೆಷರ್ ಇಂದ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಬೆಂಕಿ ಅದೆಲ್ಲ ಹೊರಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ದಟ್ ಇಸ್ ಒನ್ ಆಫ್ ದಿ ಡಿಫರೆನ್ಸ್ ಹಿಯರ್. ಆಸ್ ದ ಲೀಕೇಜಸ್ ಆರ್ ಇನ್ಸೈಡ್, ದೇರ್ ಫೋರ್ ದರ್ ಇಸ್ ನೋ ಸಚ್ ಡೇಂಜರಸ್. ಸೊ ಲೀಕೇಜ್ ಏನಾದ್ರು ಇದ್ರ ಒಳಗಡೆ ಇರೋದ್ರಿಂದ ಸೊ ಇದು ಹೊರಗಡೆ ಡೇಂಜರ್ ಬರ್ತಕ್ಕಂಥ ಚಾನ್ಸಸ್ ತುಂಬಾ ಕಡಿಮೆ ಇದರಲ್ಲಿ. ರೈಟ್. ನೆಕ್ಸ್ಟ್, ದಿ ಕಂಪ್ಯಾರಿಸನ್ ಆರ್ ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ನ್ಯಾಚುರಲ್ ಡ್ರಾಟ್ ಅಂಡ್ ಆರ್ಟಿಫಿಷಿಯಲ್ ಡ್ರಾಟ್. ನ್ಯಾಚುರಲ್ ಡ್ರಾಟ್ ಮತ್ತು ಆರ್ಟಿಫಿಷಿಯಲ್ ಡ್ರಾಟ್ಗೆ ಡಿಫರೆನ್ಸ್ ನೋಡೋಣ. ಏನು ಡಿಫರೆನ್ಸ್ ಆರ್ ಏನು ಕಂಪ್ಯಾರಿಸನ್? ಸೊ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ನ್ಯಾಚುರಲ್ ಡ್ರಾಟ್ ಈಸ್ obtained by the use of chimney. So it is a natural drought. Natural drought is created by using chimney only, because the pressure difference should be must be created naturally here, right? So once if you use the chimney, because of the density difference, the pressure difference is created. So that is in the case of natural drought. So drought is obtained by the use of fan or blower. So in the artificial drought, you must use the fan or blower for creating the pressure difference. So in the natural drought, it depends on the height of the chimney, right? So it depends on the height of the chimney. If the height of the chimney is more, the more pressure difference is created here. If it is less, then the less pressure difference is created here. It does not depends on height of the chimney. Since if you are inducing, or since if you are forcing, right? Since if you are inducing the drought, since if you are forcing the drought in this case, so it does not depends on the height of the chimney, right? There is the one more difference or comparison. Flue gases have to discharge with high temperature, right? Flue gases have to discharge with high temperature in the case of natural drought. Then the flue gases need not discharge with high temperature. It need not discharge with high temperature. Anyhow, you are using the forced or induced. So in this case, you can use the heat with the full extent. Simple in construction with less cost. So it is simple in construction with less cost. So complicated in construction and high initial cost. Right? It is simple in construction. There is no extra part like fan and blower is used in the case of natural drought. So you can in the case of artificial drought, you were using the fan and blower. So that is a complicated construction and the high initial cost is required. So in the case of again the natural drought, no mechanical parts and hence maintenance cost is less here. high maintenance cost due to large number of mechanical parts here. It does not require any extra power to produce the draught. So you need not to supply extra power for creating the pressure difference in the natural draught, right? But it requires any extra power to produce the draught. So extra power is required in the case of artificial draught to produce the pressure difference, right? Extra power means you are supplying the power to the fan or blower, right? So then next, in the case of a natural draught, it depends on atmospheric temperature. In the natural draught, it depends on atmospheric temperature. If atmospheric temperature is high, then definitely the pressure difference is less here. If the atmospheric temperature is less, then the pressure difference is more. So it is independent of atmospheric temperature in the case of artificial draught. Large consumption of fuel is required. So low consumption of fuel in the case of induced or forced draught, low thermal efficiency, because you are not using the heat for a full extent in the case of natural draught, then automatically the thermal efficiency decreases in the case of natural draught. The high thermal efficiency is here because you are using the heat for the full extent, so that the thermal efficiency automatically increased. The poor combustion of the fuel due to low velocity of air, right? And the proper combustion of the fuel due to the high velocity of the air, it creates the more smoke and prevents the smoke creation here. So this is the differences, or I can say the comparison of natural draught and the artificial draught. So now we can see the balanced mechanical draught. So as soon as you see the picture, ನೀವು ಈ ಪಿಕ್ಚರ್ ಅನ್ನು ನೋಡಿದ ಮೇಲೆ ಗೊತ್ತಾಗುತ್ತೆ, it is a combination of both, combination of the forced and induced draught here, because the blower is placed here before the furnace, this blower. So this is the forced draught, and one more blower is provided here. It is after the air free heater or before the chimney. So this is the part of induced draught. So when if you are using two blowers, or you can say the combination of the forced and induced draught, we can call this as the balanced mechanical draught here, right? So balanced mechanical draught means whatever the resistance you offer, the first blower what you are using here, so whatever the resistance you offer for the by the air free heater, that can overcome by the first blower here, this one blower. Then this blower, second blower, what you placed before the chimney, so it can overcome the very less amount of pressure is coming out of the air free heater, because the maximum amount of heat is extracted in the air free heater, so it loses its temperature. Then definitely the pressure of that air is also less, so that you can again pressurize by using the blower here. So both you can balancing in this case, so that is why it is called as balanced mechanical draught. So the draught is created by balancing the disadvantages of the forced draught as well as the induced draught. So those two you can balance here. So because of that, it is called as the balanced mechanical draught here in the case, right? This is the balanced mechanical draught. So next one is steam jet drought. So till now we have studied the mechanical drought. So now we will see the steam jet drought. So the steam jet drought means the drought, I mean the pressure difference is created by using the steam. The steam means the steam already present in the boiler. So the same steam you can use it for generating the drought. So because of that, it is called as steam jet drought. So the steam whatever available in the boiler, the steam you can pass it through the nozzle. You can use the nozzle there, steam nozzle, you can use it. Through the steam nozzle you can pass the steam from the boiler, so that the steam coming out of that nozzle is with high velocity. So the high velocity steam you are getting from the nozzle, so that is used for generating the draught. So because of that, it is called as the steam jet draught. Again, in the steam jet draught, the first type is of induced steam jet draught. So the induced steam jet draught. So that induced steam jet draught, I have shown it in the figure here. So here in this case, what happens? This is the exhaust steam from the steam engine. So the exhaust steam from the steam engine. So from the steam engine, whatever the exhaust steam you are getting, that steam you are passing here. So passing here through the steam nozzle. ಸ್ಟೀಮ್ ನಾಸಲ್ ಮುಖಾಂತರ ಯಾವುದು ಸ್ಟೀಮ್ ಎಂಜಿನ್ ಇಂದ ಹೊರಗಡೆ ಬರ್ತಾ ಇರುತ್ತೋ ಆ ಎಕ್ಸಾಸ್ಟ್ ಗ್ಯಾಸ್ ಅನ್ನ ನೀವೇನ್ ಮಾಡ್ತೀರಿ, ಈ ಸ್ಟೀಮ್ ನಾಸಲ್ ಮುಖಾಂತರ ಸ್ಮೋಕ್ ಬಾಕ್ಸ್ ಗೆ ಕಳಿಸ್ತೀರಾ. ಸೊ ಈ ಸ್ಟೀಮ್ ನಾಸಲ್ ಮುಖಾಂತರ ಏನು ಹೊರಗಡೆ ಬರುತ್ತೋ ಅದು ಒಂದು ಸ್ಟೀಮ್ ಇರುತ್ತಲ್ಲ, ಸೊ ದಾಟ್ ಈಸ್ ಆಫ್ high velocity steam, because you know already when it comes out of the nozzle, definitely there is a high velocity is there. If high velocity is there, then the kinetic energy is also more, right? So the hot gases, illinda hot gases ಕಳಿಸ್ತಾ ಇರ್ತೀವಿ. This is from the boiler. The hot gases are coming here, so that means it is a flue gases. So these flue gases should go to the atmosphere. ಸೊ ಇಲ್ಲಿ ಏನು ಸ್ಟೀಮ್ ಇಂಜಿನ್ ಇಂದ ಗ್ಯಾಸ್ ನಾಸಲ್ ಮುಖಾಂತರ ಬರುತ್ತೋ ಈ ಹೈ ವೆಲಾಸಿಟಿ ಸ್ಟೀಮ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಫ್ಲೂ ಗ್ಯಾಸಸ್ ಅನ್ನ ಅದು ತಗೊಂಡ್ಬಿಟ್ಟು ಅಟ್ಮಾಸ್ಫಿಯರ್ ಹೋಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ದಿ ಇಂಡ್ಯೂಸ್ ಸ್ಟೀಮ್ ಜೆಟ್ ಡ್ರಾಟ್. ಸೊ ಇನ್ ದಿಸ್ ಕೇಸ್ exhaust steam, right? In this case means in a induced steam jet drought, exhaust steam from a non-condensing steam engine is used for producing the draught, and it is used generally in a locomotive boilers here. This one, where the exhaust steam from the engine cylinder is discharged through a blast pipe placed at the smoke box and below the chimney. So that is shown in the figure here. So this is how the induced steam jet works now. Then next we will see what is the forced steam jet drought. Forced steam jet drought. So in this case, in the case of forced steam jet, the steam from the boiler, the steam in this case, the steam from the boiler, so that is after having been throttled to a gauge pressure of 1.5 to 2 bar, is supplied to the jet or nozzles installed in ash pit, right? So installed in the ash pit, the steam with a high velocity drags the air along the fuel bed, furnace, then fuels, and then to the chimney. So here the forced draught produced by the steam is known as turbine draught. So that is called as the forced steam jet draught, right? So the next we will see what are the advantages of the steam jet draught. What are the advantages? So it is quite simple and cheap. It has the capability of using low grade fuels, right? It occupies very less space. Initial cost is low, right? So it occupies less space, and similarly the initial cost is also low. Then the maintenance cost is low. Exhaust steam from steam engine or turbine can be used easily in the steam jet drought. Then what are the disadvantages of the artificial drought? The disadvantages are, so it can operate only when some steam is generated, right? So since this is depends on the steam only, if the steam is there, with that steam only you are passing through the nozzle, then you are creating high velocity steam at the exit, then again the kinetic energy. So if there is no steam, then you can't create the artificial drought in the case of steam jet drought. So that is the one disadvantage. Can operate only when some steam is generated. Drought produced is very low. The drought produced is very low in the case of steam jet drought. That is the one more disadvantages. So this is the end of the drought, that is the boiler drought, as well as the unit 2, that is the steam boilers.